We spent, I would say, at least a year trying to determine what was going on. Finally, she referred me to a neurologist. The neurologist came back in the room and said, "You have Parkinson's." And that kind of changed everything.
Parkinson's disease is a long-term degenerative disorder on central nervous system. Its effects are both chronic, which means they persist, and progressive, meaning they grow worse over time. Most people diagnosed with Parkinson's are either 60 years or older. By the time it is diagnosed, Parkinson's has typically already progressed at a point where people face difficulty controlling movements of their body. Swallowing, talking, walking, and completing different simple tasks become challenging. There is no definitive test to diagnose Parkinson's at the moment. Symptoms vary from person to person, and other neurobiological diseases manifest in similar ways, which means misdiagnosis can occur.
On a more positive note, there is hope. Aside from finding a cure, the holy grail of Parkinson's research is the discovery of biomarkers, which are detectable and measurable changes of the body that can help to predict, diagnose, and monitor disease activity and progression. For example, blood pressure, body temperature, and body mass index are all biomarkers. Reliable biomarkers would allow physicians to screen and identify people who are at an increased risk of developing Parkinson's. These biomarkers would then enable a more accurate monitoring of the disease progression. Effectively, biomarkers could be the key towards achieving early detection. Detecting Parkinson's at an early stage is important because then the patients would be able to get proper advice and treatment. Early treatments may help slow down the disease progression.
Recognizing the potential of biomarkers, our team, in collaboration with Coffee Lab, is working at identifying significant protein biomarkers. Protein biomarkers have caught the attention of the scientific community because, in contrast with the genome, which is characterized by its stability, the proteome actively changes in response to the organism's developmental stage and both internal and external conditions. Researchers believe that these changes could play a vital role in determining whether a person is at risk of developing certain diseases. In our project, we are building a machine learning-based pipeline that analyzes thousands of proteins that could be biomarkers. These proteins are then used to classify between Parkinson patients and healthy individuals using machine learning technologies.
In our pipeline, first the data is loaded. This data consists of several thousand of features and a few hundred of samples. Next, we explore the data to understand how the distribution of the protein intensities is different between the groups. In the same step, we deal with missing values, scale transformations, and cleaning the data. The refined data is then passed to the feature selection algorithms, where the relevant proteins are selected based on combination of statistical and machine learning algorithms. Finally, machine learning models are trained using the selected features from the step before. We obtain a model which can predict whether a patient has Parkinson's or not. Currently, the ensemble machine learning models can achieve accuracy of up to 83%. However, we believe with further refinement and verification of the selected features, better results can be accomplished.
In the first module of the pipeline, the user can upload one or more files containing either protein, peptide, or phosphorylation intensities. The pipeline then shows visualizations depending on the nature of the data. The next module will perform scaling, imputation of missing values, and log transformation on the data. The user can download or preview the preprocessed data. In the feature selection module, the user can run one or more feature selection algorithms using default or custom hyperparameters. The user can then download or preview the selected features. The user can train multiple machine learning models using the selected features. The user can view the results and graphs for each model with the accuracy scores.